Welcome back to P4. Today we're looking at using partial fractions to help simplify the expansions of more difficult expressions. So this is exactly as it sounds. We take what we've got, algebraic fraction, we split it into partial fractions, and then we expand it using binomial. Nice and easy, at least it sounds. Let's have a look. So here we have a typical question. Express 4 minus 5x over 1 plus x, 2 minus x as partial fractions. Then we're going to expand it as far as x cubed, and then we have to state the range for which it's valid at the end. So let's start with just part A. I'm just going to make a bit of room. So as partial fractions, we want a over 1 plus x and b over 2 minus x. Now that will mean that we get 4 minus 5x will be the same as the other top line, which is a times 2 minus x plus b times 1 plus x. Just obviously skipping a couple of steps there. Now if I substitute x equals 2 in, then this bracket will become 0, so I can get rid of the a. So 4 minus 5 lots of 2 equals, then we've got 0 plus 3b. So 4 minus 10 is 6, negative 6. So b is going to be equal to negative 2. Then substituting x equals minus 1 in, that'll get rid of this bracket. So 4 minus 5 lots of minus 1 is equal to. Now for a, when I substitute minus 1 in here, I get 2 minus minus 1, which is 2 plus 1, which is 3. So we're looking at 3a. And now we've got 4 minus negative 5. So 4 plus 5 is 9, equals 3a. So a equals 3. Now I can quite clearly see that this is going to be 3 over 1 plus x minus 2 over 2 minus x. Now we want to do the expansion for part B. This is what we've got when we've split this up into a partial fractions. And all I want to do then is just kind of rewrite these. So we're going to have 3, 1 plus x to the minus 1, minus 2, 2 minus x to the minus 1. And it makes sense to expand these separately. So let's do the 3, 1 plus x to the minus 1 first. So it's going to be 3 lots of, and then we get 1 plus minus 1 times x plus minus 1 minus 2 times x squared. And that's over 2 factorial, and then we got minus 1, minus 2, minus 3, x cubed over 3 factorial. And that's as far as we need to go. And simplifying inside the brackets, I get this, and then multiplying by 3, so 3 minus 3x plus 3x squared minus 3x cubed, and so on. Next we want to look at our 2 minus x to the minus 1 expansion. Okay, so first let's factorize out the 2. And then that will be 1 minus a half x. And obviously this is all to the minus 1. So we end up with 2 times 2 to the minus 1. 1 minus x over 2 to the minus 1. And 2 to the power minus 1 this is a half, isn't it? So 2 times a half is just 1. So that does mean that all we're doing is this expansion, which is quite nice. So expanding this, I get 1 plus minus 1 times minus x over 2 plus minus 1 minus 2 times minus x over 2 squared over 2 factorial plus minus 1 minus 2 minus 3 minus x over 2 cubed over 3 factorial. And obviously this carries on going forever, I just can't quite fit it on my screen here. Now simplifying this, and that gives me 1 plus x over 2 plus x squared over 4 plus x cubed over 8. And obviously it would continue on forever. Now putting both of these expansions back together in my original part here, don't forget this minus sign needs to be present. So now it's just a matter of sorting this out. So we've got 3 take away 1, so that's going to be 2. We've got minus 3x, take away a half is going to be minus 3.5 or minus 7 over 2x. Next we have 3x squared, take away 1/4. So that is going to give us our 11 over 4x squared. And then finally we've got minus 3x cubed, take away an 8th x cubed, which of course does give us our minus 25 over 8x cubed. Now finally we need to work out where this expansion is valid, and we have kind of two things to look at. So if we look at both of our expansions separately, this one's going to be valid for when x is less than 1. And then my second expansion, if you remember this expansion, we expanded a minus half x, didn't we? And that's what I have to think about. So this is going to give me this, which will give me that x is less than 2. And what I need to do is just think about them. It's kind of obvious in this case, but if you think about it visually, my first one is between 1 and minus 1. My second one is between 2 and minus 2. And quite clearly, what works for both of them is between 1 and minus 1. So that means that this is valid between 1 and minus 1. So you want to just finish it with a nice sentence. The expansion is valid, and there we have it, x or mod x less than 1. Now, I don't think this is too difficult a topic, so I'll just stick with this one example. I'll put a few questions up, and as always, I'll go through them at the end. So if you do want an extra couple of examples, just have a look at me going through the answers to the exercise. So this one was probably, or maybe not the best question, as we've got hence or otherwise. Hence usually means your previous part is the easiest way to do it. But in this case, I think it's actually much easier just to expand straight from here. 2x, x plus 3 to the minus 2. So this is where I would expand from, straight from this point here. Take the 3 out, so that'll be 1 plus x over 3 in the brackets. So you can see that 3 is to the power negative 2 here. So that would be 2x over 9. If I take it fully out, 1 plus x over 3 to the minus 2. So it's far easier to expand this and multiply by 2/9 x than it is to expand 2. Okay, so one expansion is obviously going to be quicker than two expansions.